Hello and welcome back to another deep dive on the WeCyberYou Unlocked podcast.
Hey, everyone.
If you are trying to be the smartest person in the room when it comes to, the digital world and how to keep yourself safe in it, you are in the right place.
Definitely.
Today we are tackling a monster that doesn't just hide in the dark. It hides in the places you trust the most.
It's one of those topics that sounds super technical, but when you really get into it, it's a fascinating look at psychology, trust, and just how the internet fundamentally works.
It really is. And before we get into the scary stuff, I want to give a huge shout out right up top.
Oh, yeah.
Today's deep dive is completely powered by the research from our friends at WeCyberYou. They put out this amazing, really comprehensive article on cross-site scripting attacks, and that's our roadmap today. If you're not following their work, you are missing out.
It's a fantastic resource. And the topic is cross-site scripting, or as pretty much everyone in the industry calls it, XSS.
XSS. It sounds like a secret agent or something. But here's the thing, and this is why I wanted to cover this. When most of us think about hacking, we picture that movie scene, you know the one.
The guy in a dark hoodie in a basement.
The guy in the hoodie furiously typing green text flying down the screen, and he's trying to break in.
Right, smashing against a firewall.
Exactly. It's brute force, trying to kick the door down.
The classic Hollywood version. It looks good on screen, but it's not always how it goes down in the real world.
Not at all. Because XSS it's different. It's not about breaking in. It's about getting invited in. It's about tricking a website I already trust into hacking me for you. It's more of a con artist than a burglar.
That is the perfect way to put it. XSS weaponizes trust. The scary part isn't really the code itself. It's that the vulnerability lets an attacker inject their malicious code into a website you think is legitimate.
So I go to my favorite social media site, my online bank, a news site.
Places you feel safe. And the act comes from them.
Yeah.
Or it looks like it does.
That is terrifying. It turns the safe zone into the danger zone. It's like going to your best friend's house and they serve you food that someone else poisoned without them even knowing.
That's a very good analogy. The website, the host, has no idea it's hurting you, but the damage is still done.
Okay, so we've got a lot to get through. We're going to break down how this works, the three main flavors of XSS,
Yes.
one of which is so sneaky it never even has to touch the server, and of course how to stop it. But first, let's define the beast. What is cross-site scripting?
So, at its core, cross-site scripting is a web application security vulnerability. But the phrase you really need to hold on to here is client-side.
Client-side. Let's pause on that. In plain English, that means the code is running on my machine, right, in my web browser.
Yes. Think of it like this. When you visit a website, the server is like a chef. It prepares a dish, the code, the HTML, the JavaScript, and sends it to your table, your browser. Your browser's job is just to eat what it's served, to render the page. XSS lets an attacker slip their own ingredients, their malicious instructions, into that dish before it gets to you.
And my browser just eats it.
It does. Browsers are built to be obedient. They don't know that this bit of JavaScript is bad and that one is good. If the website it trusts says, run this script, the browser just runs it.
So it's a Trojan horse, and the website I trust just opens the city gates for it.
Pretty much, yeah. The website thinks the code is just content, maybe a comment on a blog or a user's bio, so it serves it up. And your browser goes, oh, this is from a trusted site, must be okay. And boom, it executes it.
The WeCyberYou article breaks this down into a 5-step process that I found really helpful. Can we walk through that?
Let's do it. Step 1 is the setup. A website takes user input. This is everywhere. Comment sections, search bars, contact forms.
Anywhere you can type something in. So I'm on a forum for, I don't know, dog lovers. I type a comment about golden retrievers. That's step 1.
Right. Step 2 is the failure. The website's code fails to validate or filter or encode what you typed. It just takes it and says, great, I'll show this to everyone.
It doesn't check if I wrote, I love golden retrievers, or if I wrote a malicious script. It just blindly accepts it.
Spot on. Which leads to step 3.
Yeah.
The attacker exploits that blind trust. Instead of a nice comment, they inject a malicious script, usually JavaScript.
And now the website has saved this little bit of poison in its database thinking it's just another comment.
And that's step 4. The website displays that code. So later, when other people visit that page, the server pulls that comment and sends it to their browsers.
And step 5.
Step 5 is the payoff. A victim, you, me, anyone, loads that page. Our browser sees the script, assumes it's legitimate because it's coming from the dog forum, and just runs it. No warning. It just happens.
That is so stealthy. So I'm just reading about dogs, and in the background, this script is doing what? Which brings us to the so what part.
This is the crucial part.
Right, because if it just pops up a funny window, that's annoying. But are we talking about real damage?
Well, you might see it used for pranks, sure. But the risks WeCyberYou outlines are much more severe. We're talking about criminals. The number one goal is stealing session cookies.
Cookies, we all click accept on them. Why does a hacker want my cookie?
A session cookie is like your ticket to a concert. Once you're inside, you don't have to show your ID at every single door.
Okay, that makes sense.
When you log in with your password, the website gives your browser a cookie. That cookie says, hey, this is still Jane. She's already authenticated. It's what keeps you logged in as you click around.
So I don't have to type my password on every page.
Exactly. But here's the nightmare. If an attacker steals that cookie with XSS, they can just take your ticket and walk right into your account.
Wait, they don't need my password?
No password needed. No username. And here's the really scary part. Often, no two-factor authentication code either.
Whoa, hold on. I use 2FA on everything. You're saying XSS can bypass that?
Well, think about it. You use 2FA to get the cookie to get your ticket. Once you have the ticket, the server considers you authenticated. If the attacker steals that valid ticket, the server just thinks they're you. They're already past security.
That is incredibly unsettling. It's a full account takeover, and I might not even get a new login notification because the system thinks it's still me.
That's right. It's totally silent. And once they're in, they can change your password, lock you out, steal all your data.
The source also mentions they can capture keystrokes.
Yeah, keylogging. The script can just sit there and record everything you type on that page, passwords, credit card numbers, you name it, and send it straight to the attacker.
So even if they don't get the cookie, they could just watch me type my credit card number into what I think is a safe checkout page.
Yes. Or they can display a fake login prompt. You're on a website, a box pops up that looks exactly like the real thing, and it says, your session has timed out. Please log in again.
I've seen that a million times. I would probably just type my password in.
Most of us would. But that box wasn't from the server. It was from the attacker's script. You just handed them your credentials.
It's phishing, but from inside the castle walls. You can't even check the URL because the URL is correct.
And that's what makes it so dangerous. It breaks the rules of trust we all depend on.
The article also notes that XSS is often just the first step.
A very crucial point. It's the entry point. Once they have your session or your password, they can pivot, use your account to attack your friends, download private data, you name it.
Okay, so we know what it is, and we know it's really bad. But I noticed in the WeCyberYou research that it's not a one-size-fits-all attack. They break it down into 3 main flavors.
Right. And knowing the difference is key. They are stored XSS, reflected XSS, and DOM-based XSS.
Let's do them one by one. First up, stored XSS, also called persistent XSS. The article calls this the most damaging type. Why is that?
Think of stored XSS as a landmine. In this case, the malicious code is actually saved or stored on the server itself.
So this is our dog form example again.
Yes, the classic case. Comment sections, user profiles. The attacker posts the malicious script one time, the server saves it. The trap is now set.
And it just sits there, waiting.
Exactly. And every single person who views that comment or loads that profile gets hit with the malicious code. If an attacker puts this on a really popular page, they could infect thousands, even millions of users.
The scale is huge. They don't have to target anyone specifically. They just poison the well and wait.
And that's why the impact is so high.
Yeah.
It's persistent. It stays there until someone finds it and deletes it.
Okay, that's stored. So what about number 2, reflected XSS? How's that different?
With reflected XSS, the script is not saved on the server. It's embedded in a URL or some other input, and it's basically reflected right back to you from the server.
In a URL. So this is where those crazy, long, weird-looking links come from?
Often, yes. For this to work, the attacker needs to trick you into clicking their link. They can't just set a trap and wait.
Ah, so this needs some social engineering.
It's all social engineering.
Yeah.
An attacker sends you a phishing email or a message saying, hey, check this out, or says you in this photo. The link looks like it goes to a real site, but at the end of the URL, they've hidden their script.
So I click the link.
You click it. Your browser sends that whole URL to the server. The server might have a search page, for example, and it sees the script in the search query and says, okay, here are the results for, and it repeats the script back in the page it sends you. Your browser sees the script and runs it.
So the server is just echoing what I was tricked into sending it.
Correct. The trigger is your click. If you don't click that specific malicious link, the attack doesn't happen.
Which is why the impact is considered moderate. It requires me to mess up first.
But attackers are very, very good at making you click things.
Right. Okay, the third one, DOM-based XSS. This one felt a little more complex.
Yeah, this is where it gets really interesting. DOM stands for Document Object Model. You can think of it as the map your browser creates of a web page so it knows how to display everything.
Okay, the map analogy. I like it.
So in a DOM-based attack, the vulnerability isn't on the server. It's in the client-side code running in your browser. And here's the twist. The malicious input might never even reach the server.
Wait, the server never sees the attack?
It can be completely blind to it.
How is that even possible?
So the server sends a generic map. But then, scripts running on your own computer change that map based on local data, like the part of the URL that comes after a hashtag symbol. The server doesn't even look at what's after the hashtag.
So the server sends the page, and then my browser says, oh, look at this info in the URL after the hashtag. I should use that to change the page. And that's when the attack happens.
You nailed it. The legitimate JavaScript on the page takes that data from the URL and uses it unsafely. The entire attack happens inside your browser.
That sounds incredibly hard to detect. If the server doesn't see it, I'm guessing firewalls miss it too?
But they often do. A firewall is like a security guard at the front door of the server. If the attack happens entirely in the living room, the guard at the front door sees nothing.
That's a great way to put it. Okay, so we have stored the landmine, reflected the baited trap, and DOM-based the inside job. Let's talk about who's at risk here. The source material mentions social media, education portals, e-commerce.
Pretty much any modern interactive website.
Yeah.
But the WeCyberYou article really put a spotlight on social media platforms like TikTok or Instagram.
That's huge for any creators or even students listening.
For sure. If you're a creator, your account is your brand, your business. XSS can be used to hijack verified profiles. An attacker gets in, starts posting malicious links to all your followers.
And because it comes from your trusted, verified account, your followers click it.
And the cycle continues. They can harvest follower data, ruin a reputation. It can mean huge financial losses.
The article gave a simple example that really stuck with me. It wasn't some big bank heist. It was just a blog comment.
Right. It's so mundane. User A leaves a comment with a script on a blog. The blog doesn't filter it. Later, user B, let's say they're on Descript, the blog admin loads the page to moderate comments. Instantly, that script runs and steals their session cookie. Now the attacker is the admin of the blog.
It's just silent. That's the part that gets me. It's not loud, it's a whisper.
And that's why it's so effective.
All right, now that we're all sufficiently paranoid, let's talk defense. We have to give people tools here. The article breaks this down nicely into two parts, one for developers and one for everyday users. Let's start with the developers, the people building these sites.
Okay, if you're a developer, the golden rule is simple. Validate and sanitize all user input. Never, ever trust data that comes from a user.
Never trust user input. I feel like that should be on a t-shirt for every programmer.
It really should. Treat it like it's radioactive. You have to handle it carefully. If you expect an email, check that it's actually an email and not a script.
The article also mentions output encoding. What's that?
That's your second line of defense. It means when you're about to display some text back to the user, you convert any special characters into a safe format. So a symbol, which starts a code tag, gets turned into something the browser just displays as text.
So the browser sees the symbol but doesn't treat it as a command.
Exactly. It defuses the bomb. It sees text, not code.
The article also mentions a content security policy, or CSP.
CSP is super powerful. It's basically a guest list for your website. The server tells the browser, you are only allowed to run scripts from these specific trusted places. Ignore everything else.
So even if an attacker injects a script, the browser looks at the list, sees the script source isn't on it, and just blocks it.
It's a fantastic layer of defense. Plus, using modern frameworks like React or Vue, which have built-in protections, and of course, regular security testing, you have to check your own logs.
Okay, so that's for the builders. What about the rest of us? The everyday users, what can we do?
First and foremost, vigilance. Be suspicious of unexpected pop-ups or weird redirects. If a site suddenly starts acting strange, just close the tab.
And for that reflected XSS threat, the one in links.
Don't click suspicious links. It's the oldest advice in the book, but it works. If you get an email from your bank with a link, don't click it. Go to the bank's website by typing the address in yourself.
That seems to be the universal rule. Just type it yourself. You avoid so many traps.
It saves you from so much trouble. Also, the article recommends logging out of your accounts, especially on shared computers.
Oh, that's a good one.
Yeah.
Because the session cookie is still alive if you're logged in.
Right. Don't just close the browser window. Actively click Log Out. And finally, the boring but essential one, keep your browser and your extensions updated.
It's like the digital version of eating your vegetables, just do the update.
It really is. The browser makers are constantly patching these kinds of holes. Running an old browser is like leaving your front door wide open.
So zooming out, what's the big takeaway here?
I think the main lesson from the WeCyberYou source is that XSS turns a website you trust into a weapon against you. It exploits that fundamental assumption of safety to steal data and hijack accounts.
It really makes you rethink what safe browsing even means. Just because it's a big, reputable brand doesn't mean every single part of their site is secure.
And that's the key. We think big site equals secure, but all it takes is one little unvalidated input field.
I want to leave our listeners with a thought. We talk about chains of trust. You trust your browser trusts the website. But what happens if that website trusts unverified input from a complete stranger? Who is actually in control of what's on your screen?
That's a great question. It shows you how fragile that chain of trust really is.
It really does. I hope this deep dive made everyone a little more paranoid, but also a lot more prepared. Awareness is always the first step.
Awareness is the best defense.
For sure. And speaking of being aware and prepared, I want to remind everyone again that this deep dive was brought to you by the team at WeCyberYou.
You really just scratched the surface.
If you want to keep learning and stay ahead of these threats, please go follow our channel and visit WeCyberYou.com. They have so much amazing educational content just like this. It's the best way to level up your game.
Highly recommended. Go check out their full article on XSS while you're there.
So go check them out, WeCyberYou.com. That's it for us today on the WeCyberYou Unlocked podcast. Stay curious, stay safe, and think before you click.
Goodbye, everyone.